All right, so here is the data that we recorded, and we put it down in order, okay? And this is in seconds. So let's talk about that real quick. Go up to the top there. So this was in, what was this distance? What was this 1,500 feet?
2 laps.
Oh, sorry, feet, right? And this was in seconds, right? We had to convert all those so that we're all in 1 unit, right? So then we're going to end up with a speed in feet per second. So can we kind of go around the room and convert all of these into feet per second, into feet per 1 second, okay, if we will. So we've converted all this to we've converted all this into feet per second, and now we need to convert it into miles per hour. So let's start with this one as an example. So I'm doing 18.1 miles per feet per 1 second. So now I need to convert it into miles per hour. So what do I need to do?
Times it by 3,600.
Right, because there's 3,600 seconds in 1 hour, and that's going to convert our seconds over. Okay. And then we want to get rid of feet, so we're going to do 5,280 feet in 1 mile.
So it's 65,160 divided by 5,280.
So the first one would be 12.3 miles per hour.
Nice. Can we put the step? So what was that step that you told me? 12 point what did you say?
Well, the answer is 12.3 miles per hour.
And tell me, what was the step that you were putting in between here?
I divided.
What did you get when you multiplied this?
65,160.
65,160. Like that?
Yeah, and divided it by.
And that is feet times. So these are all canceled, and we get miles, right? Over 5,280 feet. And then Aaron divided that out and got to be 12.3 miles per hour. Okay, so that's one example. So why don't you, what we'll do is everybody will go through and pick the same one, and let's convert all these into miles per hour. All right, so the mean was 10.6.
So you got in?
I got 10.507.
Yeah.
507.
That's what I got.
Okay, so 10.5.
Oh yeah.
Okay, 10.5 for the mean. Okay. 10.3 for the median because it would be these two, right? The median, these would be the two middle ones, and so you would take the average of those, so that would be 10.3. So 10.3 would be the median speed. What would be the min speed?
7.2.
7.2. And the max speed would be 12.3. Okay, don't worry about these things here. Okay. All right. So what number, now, so we're going to keep all these, and then for a mode, let's throw in a mode speed was 10. Okay? And, is everybody okay with that? Okay. Now, so there we go. So what do we feel with, what number do we feel might best represent this set of data? 10. We like 10?
Okay, so I feel like 10 miles an hour, it's in between 7, it's in between 12. And it seems to be pretty reoccurring. And 10 miles an hour seems like a really decent pace to be able to maintain if you have a trailer and you're going down like that.
Okay. Yeah, so it was the mode, as you said, right? It's what we found it with the hauling bikes. And we, it's a nice number to work with, right?
Yeah, it is.
Nice number, okay? Okay. So that we feel like that's going to be, we're going to use that quite a bit. Okay. Yeah.
Time.
Time. Oh, thanks.
Reminding you.
Thanks. So now let's see what's on the next page. Now we may stick with this. Okay. Now I actually want to do I want to talk a little bit more about unit conversion, just a little bit in the end of this class. And now let's go on to this page. All right. So let's talk a little bit about functions. Okay. Tonight, your homework is to learn more about functions. Okay. I sent you a video. Maybe, well, I haven't sent it yet, but I will send you a video about functions. Okay. Now, functions are special types of relationships between two variables. Okay. And it implies that one depends on the other. Okay, so we're going to talk about those relationships a little bit. Yeah. Got it. So I'm going to pause this for just a little bit. Again. So we call it d of t, right? And what we're saying is that the distance traveled, it depends on the time that we are going, right? So if you're going, given a set distance, a set speed, like you're going 5 miles an hour, right? If you go for 2 hours, you're going to go further than if you only go for 1 hour, right? So your distance traveled depends on how long you go at that speed, okay? Blah, 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 blah. So I want you to look at these variables below, and I want you to think about which is the dependent variable. So I want you to circle the independent variable. So in this case, it would be time. Okay. And then I want you to write a sentence in the form of distance. The distance depends on the time. And then I want you to write an equation for that function. So for example, here's a little example here. Number of people in the family, dollars spent at the grocery store weekly. So we would say dollars depends on the number of people, right? Because you got more people, they're going to eat more. And I'm just going to randomly pick 50. So for every person, it seems reasonable that for each person you add $50 to your weekly grocery bill, right? So my equation would be like this: D of P equals 50P. People kind of say that?
Wouldn't it mean that D is 50?
Well, if there were 5 people, right, how much would it equal? 250, right? If there were 10 people, it would read $500, right? So.
But it still means that D would be 50 though.
So this does not mean, this notation here does not mean D times P, right? It means that D depends on P, and that this is the same thing as Y, right? So we could also write this equation like this: Y equals 50x, right? So I see what you're saying. This doesn't mean D times P, okay? It means D depends on what P is, and it's nice because if I'm working with lots of different equations, right? Then I can say, well, maybe I'm worried about D of P or, F of X or whatever, okay? So this you can think of as Y. You don't ever do any math to this thing right here, okay? But does everybody see what I want you to do here? I want you to go through and circle the independent variable. So the number of people in the family is the independent variable in this case, because the dollars spent depends on the number of people. More people, you're going to spend more money. And then here's my equation. So I want you to do each of these steps for these next ones down here. Okay, so just work on that, and we'll write it up here on the board in a second. So which one do people think is the independent variable?
Shots taken.
Shots taken is the independent variable, right?
The score of the game depends on the shots taken.
Okay, shots taken is the independent, right? The score of the game depends on how many shots are taken.
So S of T equals is 16T for any number T.
Now, if this was a soccer game, right, would 16T be a good game? Good.
Yeah.
It'd be like CRMS style.
Yeah, how about like 0.25 T?
Wait, no, you can't have 0.25 on the point.
Not shots made, but shots taken. Right? So this would imply that if you shot 4 times, you'd get one. You'd probably get one of those in the goal.
Oh,
Right?
Wait, 1/3.
What?
Wait, 1/3.
You did 1/3.
So you did 3.
It's
You-
10.
What?
Okay.
Yeah.
10.
Now, if you were playing basketball, right?
Yeah.
Then you might have a different ratio there, right? Or you could say 2 points or 1 point for every shot taken, so that when you get 2, you get a bucket, right? Or something. How about
4 pointers.
what?
Get 4 pointers.
3-pointers?
I like how they're all number 1.
All number 1. Whoops. Guess I should fix that. How about number of gallons bought and total price of the gas station fill up?
The total price of the gas station at fill-up is
Uh-huh.
dependent upon the number of gallons bought.
Okay, so T of N. So this would be my independent variable.
How many gallons are usually in a car? Like 20, 24?
Depends. Like a little car is like can
16?
have is like 9.
Oh, really?
Yeah, my Honda Odyssey is 16.
Okay. So I
Okay.
said 16.
So you can have that.
Okay.
Yeah.
So number of gallons bought and
So I said like 16N.
okay. Well, now what? Now price. What are the units of price?
Oh, money.
Money, right? So right now it would be like 350 per gallon, right?
Ah, I get it.
Wait, why is the number of gallons bought?
We're done with class 2, Peter.
No, why is that one? Because if you buy 5 gallons, it's going to cost you more than buying 4 gallons, right?
Can we do the third one really fast?
Yeah. Hours of homework and GPA.
The GPA depends on the hours of homework.
Yeah, so
That's
G
not
is
true, but-
going to depend on H, right?
We're done.
Yeah, I know.
Okay.
Okay.
We're good?
Yeah.
All right.